weekend. Thanks. It was good. Those was nice. So yeah, when we got to like. Did you lose the left hand?
Okay, we're going to start trig unit today. There is a lot with trig from you saw from previous years, but we're only going to focus on the parts that is going to affect us from a calculus perspective. So the two most important thing that I want us to make sure that we can do is being able to find trig values, so solving trig equations, and also unit circle, being able to get those unit circle values. And that's the most important thing. We don't have to worry about graphing. We don't have to worry about having to memorize a bunch of properties like double angle, or half angle. So we're just going to focus on just the parts that's going to matter for us. So today, I want us to just focus on trig review, unit circle values, and then being able to solve equations. So we'll do a unit circle review. Just to let you know that on the quiz and on the test, I'll give you scratch sheet for you guys to create your unit circle, but I'm not going to give you a blank unit circle to work with. So because they're not going to provide that on the AP exam, so I want to make sure that we know how to survive without a blank unit circle. So you'll be creative.
Like, is there two parts to this unit?
I'm sorry?
There's two parts to this unit.
Right. So we're going to, so let me talk about that. We're just going to focus on the derivatives. You know how on the quiz that you just took where there was product rule and implicit and there's no log differentiation here, but being able to solve those derivatives or find derivatives and all those derivative topics that we did, we're just going to focus on that for the quiz. So the quiz will be the Wednesday after Thanksgiving break. We'll have tomorrow and Thursday and Friday to review. Wednesday will be senior service day. So for any students who are going to be here, it'll just be a study hall. And then when we come back, then we'll do part 2 where the curve sketching, the related rates, and there's a little bit more derivative rules I would learn.
They're not like 2 separate tests, right?
Yeah, so it'll be a quiz on Wednesday, and then after we get back, it'll be that Monday of that finals week. Yeah.
That's the last test of the whole.
That's right, yeah. So there's only 2 grades remaining, quiz and the test. All right, any questions? Okay, so your homework tonight will just be from page 7, solving trig equations, and then the key is on page 8. I'll send out a reminder this afternoon. Okay, so unit circle values are all based off of trig ratios for 30, 60, 90 triangle and for 45, 45, 90 triangle. They're all kind of based off these ratios here. Remember, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. Okay. Likewise, the reciprocals will also stand for the other trig functions, right? So cosecant is hypotenuse over opposite. Secant is hypotenuse over adjacent. And then cotangent is adjacent over opposite. So the most important is just the first quadrant. If we can figure out the first quadrant, everything else is kind of building off of that. All these, imagine this is just the coordinate plane here. So if I go up 1 unit, down to the left, to the right, up or down, those are all just 1 unit away. So the order pair there is 1, 0. And the order pair above here is 0, 1. All your order pairs will follow this pattern here. Basically, your x coordinate will be your cosine, and your y coordinate will be your sine. Okay, so just think alphabetical. C followed by S. Okay. So all your order pairs, they're all kind of based off of this these special right triangles here. So I like to build this pattern here where I start at the upper left corner of my of all my order pairs, and I'm just going to and also everything is over 2. And we just start at the upper left corner and we just count. We go 1, 2, 3, and then we count back up. 1, 2, 3. Put square roots over all the numerators except for 1, because if I put a square root of 1, square root of 1 is just 1, so I can leave that alone. So root 3, root 2, root 2, root 3. So what's this is so helpful for us because everything that we need, we can just pull from these order pairs. So if I want to find cosine of pi over 3, that's the x value. So cosine of pi over 3 would just be 1/2. Sine of pi over 4 will be just the y value at this location, root 2 over 2. Sine of pi over 6, which is will be 1/2. Cosine of pi over 6 will be root 3 over 2. So let's try example 1 here. It says find find the values of all trig functions at 60 degrees. 60 degrees is pi over 6. 45 degrees is pi over 4. And then pi over 6 is 30 degrees. Right? So thank you. Okay, what's sine of pi over 3? Yeah, root 3 over 2, just a y value. Okay, what's cosine of pi over 3? Okay, anyone remember what's the tangent of pi over 3? Yeah, so tangent is y over x, sine over cosine. So that's another property that we're going to make sure that we know. So it'll just be the y over x. Now, technically, you may be thinking, well, shouldn't it be root 3 over 2 all over 1/2? And it is, but the nice thing is that your denominators are all the same, so you can just make them cancel out. So really, whenever I do y over x or anything with cotangent or tangent, I just cover up the denominator and I say, okay, y over x is just root 3 over 1. Okay. I mean, you can do this, but you know that your 2's will always cancel out. And then your cosecant, secant, and your cotangent, you're just doing reciprocals of sine, cosine, and tangent. So cosecant of pi over 3 is just the reciprocal of sine, which would just be what? 2 over root 3. Now, you can leave it like this, but sometimes your answer may be presented with the radical rationalized. You don't have to do it if it's free response, but just know, that these are equivalent, right? If I multiply numerator and denominator by √3, I get 2√3/3. Right? Secant is just the reciprocal of cosine. So what's secant of pi/3?
2.
Just 2, right? And then if tangent of pi/3 is √3, then cotangent will be what?
1
1/√3.
you rationalize.
And if I want to rationalize, it'll be, yeah. Now, either form is fine, but just it's good to recognize another variation of it if you're forced to having to adjust to that. But free response, your radicals in the denominator is never gonna, you're never gonna have points taken off because you left a radical in the denominator. We'll come back to 225 degrees. Let me just go through a few things here. We'll come back to this one because I want us to build the unit circle, review all that with unit circle, and then we'll focus the rest of our attention on just solving trig equations. Okay. Now, we have to be able to go back and forth between radians and degrees, but mostly just be able to recognize radians. Radian is simply the angle formed when the radius is wrapped around the outside of the circle. It takes 2 pi radian to get all the way around the circle. So it takes pi radian to get halfway around. Okay, so that means pi radian equals 180 degrees. Okay, we're not going to have to worry about graphing, so we can cross off example 3. Period amplitude, that's not going to show up on the AP exam. Okay, I'll come back to example 4. Let's do a unit circle. Let's go through a full unit circle just to kind of have a let's see. I'm going to work off of page. I like 6C here. All right, so everything is off of first quadrants. So again, I'm going to just build all this. We're going to just pull everything from here. So this is 1 unit away. Okay, there's also this left-hand memorization trick. If you're having trouble with this, I'll show you another way of memorizing that first quadrant. But just to kind of give you a bunch of options and see if you're see if any of these stick with you. Okay, so let's start with the most basic. The most basic are the ones along the axis. So these are all just 1 unit away. So imagine you're just going left 1, up 1, left, right, and down 1 unit. So okay, in terms of degrees here, this is 0 degrees, 90 degrees, 180, 270, and then 360. In terms of radians, 0, pi/2, pi, 3 pi over 2 and 2 pi. And 2 pi and 0 are sharing the same values. Okay, so we know this is 30 degrees, 45, 60 degrees. I'll go ahead and fill out the first quadrant again. Okay, degrees are not as important, but it's important. I mean, we have to know kind of, you know, where it links up with. So in terms of reference angles, the reference angles just means how far we are from the x-axis. So the closer, all the angle measures that are closest to the x-axis are just 30 degrees away from either 0, 360, or 180. Okay, so if I'm going 30 degrees from 180, 180 minus 30 will be 150. If I go 30 degrees to above 180, I get 210. Right. If I go 30 degrees less than 360, I get 330 degrees. And then 45 degrees will be the middle. So all the middle angles, the middle diagonals will be 45 degrees less than, greater than 180, or less than 360. We already have this one filled out. So 180 minus 45 will be 135. 180 plus 45 will be 225. 360 minus 45 will be 315. And then all the diagonals that are furthest away from the x-axis will be 60 degrees from the x-axis, right? So either 180 minus 60 or 180 plus 60. Remember, just make sure that you never do any of this from the y-axis. Okay, make sure that you always count, or if you're doing any reference angles, don't do 90 plus 30 and thinking, you know, that'll mess things up. Everything's with the x-axis. Okay, so 180 minus 60 is 120. 180 plus 60 is 240. 360 minus 60 is 300. Okay, so the more important ones are the radians. Okay. So radian measures pi over 6. That's equivalent to 30 degrees. You can always convert back and forth between these two if you're having trouble. Is that your let's see. Degrees. So to go from degrees to radians, you're always either multiplying or dividing by 180 over pi. So if I do 30 degrees times pi over 180, that will give me 2 pi over 6. Okay, 45 degrees is pi over 4. 60 degrees is pi over 3. So I feel like maybe the easiest, this is one way to kind of help remember where all the radian measures are. All the ones that are closest to the x-axis, closest to the x-axis, they all have a denominator of 6. Okay, so they all have denominator of 6. So I know it's going to be something over 6. This is going to be something over 6. All the middle ones will have a denominator of 4. And then all the ones that are furthest away from the x-axis will all have a denominator of 3. Okay, so I think one way to remember what all these radians measures are is that all your numerator in your second quadrant will be 1 less than your denominator. So what's 1 less than 3? 2. What's 1 less than 4? 3. And 1 less than 6? 5 pi. So there we have it. So 2 pi over 3 is for 120 degrees. 3 pi over 4, okay, 5 pi over 6. Everything in the third quadrant will be 1 unit greater than a denominator. So what's 1 more than 6? 7 pi over 6. 1 more than 4. And then 3. So anything in the fourth quadrant is a little bit more involved there. You're gonna have to double your denominator and then subtract 1. Right? So if I double 3, I get 6. 6 minus 1 is 5. If I double 4, I get 8. 8 minus 1 is 7. If I double 6, I get 12. 12 minus 1 is 11.
Like, I know radians equals degrees is times pi over 180. Can you say like degrees equals like radians times 180?
That's right. You can also go backwards as well. Your degrees is your radians times 180 over pi. So whatever your 30 degrees is, your order pair will be the same for all the ones with a 6 in the denominator. So all the ones that I highlighted in green, closest to the x-axis, will all have these order pairs. Anything in the middle will have the same order pairs all the way around. Anything that's furthest away from the x-axis will have the same order pairs. Okay, so just copy all of them down. The only difference is that the signs will be maybe different with different quadrants, but all the numeric values will be the same. So we'll just copy anything that is closest to the x-axis will have these order pairs. All the middle ones will have root 2 over 2 and root 2 over 2. All the ones furthest away from the x-axis will be 1/2 root 3 over 2. Okay, let's think about the signs here. We know the first quadrant order pairs will be positive, positive. In the second quadrant, all the order pairs will be what? Negative, positive, right? You go left, that's negative. You go up, that's positive. So negative, positive. So I can make all my x values negative and keep my y values positive. So negative, negative, negative. Okay, what about the third quadrant? All my order pairs are what? Negative, negative. So anything in the fourth quadrant, positive, negative, right? So all your y values are negative here.
We can memorize this, right? Like, without drawing it too.
Right, right. But hopefully everything, you can just spend a few seconds to build the first quadrant and then everything else will just come to you. Hopefully you don't have to create everything just to solve one problem, right? Hopefully this is enough to get to that one problem, right? Because you know that anything all the ordered pairs will just be either this, this, or this, and then depending on which quadrant you're in, you know which one is going to be positive or negative.
Well, you should give you like the quadrant or like something for that quadrant to give you like a hint.
Well, I think the idea is that if you look at your radian measure, hopefully you'll know which quadrant you're in, right? If you see your numerator is less than your denominator, you know you're in the second quadrant. If your numerator is more than your denominator, you know you're in the third quadrant. If it's close to doubling the denominator, you know it's got to be in the fourth quadrant. So everything, most everything's going to be radian measure, except for, this example that we're going to see here. So let's try going back to example 2 here. So use these to find the values of 225 degrees. So 225 degrees, that's going to be in that pi/4 family. In which quadrant? Third quadrant, right? Pi/4 family in that third quadrant. So pi/4 will just all be √2/2 and √2/2, right? This is basically it. But you know that anything in the third quadrant, both your x and y values are what? Are both negative, right? Okay, so let's just do sine, cosine, tangent for all of these. Okay, 225, I'm going to write 5/4. Okay, so what's sine of 5/4? Yeah, -√2/2. Okay, what's cosine of 5/4? Yeah, x value, right? Right, what's tangent of 5/4? 1, right? Because I have -√2/2 divided by -√2/2. These will just cancel out. All I'm left with is a +1. 2 negatives also makes positive. Okay, and then cosecant, secant, and cotangent, I'm just flipping my original 3. So what's cosecant of 5/4? Yeah. So it's -2/√2, which reduces to be -√2. Secant, same thing, right? Flipping the same number. And then cotangent of 5/4. If I flip 1, I still get 1.
How do you apply that to -2 for difference?
Oh, from here to here?
Yeah.
If I rationalize the denominator.
If brings forward up will help like
Mhm.
1 in the denominator.
So I get -2√2/2, which is -√2. Sorry, yeah, -√2. Because the 2's cancel out. Okay, example 4. Sine of 2x equals sine x. There is a double angle for sine 2x.
Those identities.
Right. That's going to be 2 sine of x cosine. So if I want to make that substitution, I get 2 sine of x cosine x equals sine of x. I don't want to divide by sine. I'm going to lose a solution here. Let's bring everything over to one side. Subtract everything to one side so we get that 0 to show up. So I'll get 2 sine of x cosine x minus sine x right, so now this turns to a little bit of a factoring problem here. Is there a GCF? Which is sine of x. Okay, what's left in my parentheses? Good. All right, I'm dividing everything by sign, so I'm just putting my leftovers in the parentheses. And we use the space here just so I can make sure I have enough. I'm going to set both equal to 0. Okay, so when is sine equal to 0? When is sine equal to 0? Yeah, so sine is equal to 0. We look at our, if you want to look at your unit circle again. Basically, when is my y value going to be equal to 0? Because I know that sine is my y value. So you know that it's going to be only zeros or ones in the along the axis. So the only place that I have y's being 0 is at 0 and pi. Okay. And we know that we don't include 2 pi because our domain does not include 2 pi, so just 0 and pi. Okay, 2 cosine x minus 1 equals 0. If I solve for cosine, okay, so we ask ourselves, when is cosine equal to 1/2? Good. So in the first and fourth quadrant, that's when cosine will be positive. So pi over 3, and then the variation of pi over 3 in the fourth quadrant is 5 pi over 3. Remember, you double the denominator, subtract 1. So
In the first part of the problem, how did you get the 2x from the sign away? Like in the first part.
right. So this is just not an identity here. Sine of 2x is 2 sine x cosine x.
Oh, it's just like
Yeah.
you can't like move it over.
No, I just I took this and I put this in for my original equation.
Okay.
I'm trying to get that sine 2x to be something I can work with, so I did 2 sine x.
Wait, when did you have to go like memorize trigonometry too?
I'll just point out a few of them. This one is important, and then also Pythagorean identity. I'll go through those.
Double angle one?
This is the only double angle we really have to worry about. Now there is also cosine, but for that I'll probably give that to you. But let me point out where those are. One more thing I want to point out about this is something that helps with knowing what the positive and negative signs are. This acronym ASTC. Okay, so this means all your trig functions are positive in the first quadrant. Here, everything is negative except sine. So sine is the only positive one in the second quadrant. That means all the y values are positive, right? But your cosine, your tangent are all negative in the second quadrant. The only thing that's positive is sine and its reciprocal. So sine and cosecant. Here, only tangent and cotangent are positive. Everything else is negative. And then here, fourth quadrant, only cosine and secant are positive. Everything else is negative in the fourth quadrant. And we're going to work on page 7. Try to do as much as we can before, and whatever we don't finish, you guys will do for homework. But let me point out what's important on 8C in terms of. Okay, SOHCAHTOA, we should know these already. Okay, identities. These are the most important ones here. Sine squared plus cosine squared equals 1. Double angle identity. Okay, you're going to see cosine 2 theta show up in your homework. Won't make you memorize these, but that will, we're going to be using those. Obviously, unit circle values, we need to know that really well. And then these other properties in the graph is not, we're not gonna have to worry about those. So those are the most important ones.
The BC, I think.
I'm sorry?
The BC.
Oh, no. Okay, let's go to page 7.
Why do you have one of them and please put on your business? I don't know the most important.
Yeah, this one, I feel like you're gonna see it in your homework. So I do want you to know where to find it if you need it. All right, so 31. 31 says 2 sine squared theta equals 1. We can divide both sides by 2 just to, we're trying to get it all the way down to sine theta if possible. Okay, what can we do next? Take the square root. Okay, now what's going to happen when you take the square root and there's an equation? It's going to pop up on the right, plus or minus. Okay, so that means we're trying to find out where is sine equal to plus or minus root 1/2. Now, root 1/2 is same thing as what? Yeah. So basically, all the variations in that pi over 4 family, we want to list out. So theta can be pi over 4. What else? 3 pi over 4. Yeah.
Is there already like I remember like we did the like limits to it too. Not like the biggest ones, but there's like extraneous solutions.
Right. I think the only extraneous solution we got to worry about is that we got to make sure that it falls inside the interval. If it's outside the interval, we don't want to keep it. Okay, let's try 32. Square root, right? Plus or minus. So again, all 4 quadrants. Where is tangent equal to root 3? Pi over 3, right? That pi over 3 family. Right, tangent is just sine over cosine, so root 3 over 1 would be that pi over 3 family. Okay, so all the variations of pi over 3. Okay, 33. What do you think we can do first here? Yeah, let's factor out the tangent. Which means I'm really dividing by tangent.
Theta goes with it.
Tangent theta minus what? Minus 1. So we got to ask ourselves, where is tangent equal to 0? So tangent is y over x, right? Sine over cosine. So we know it's going to be along, has to be along the axis.
Remember, root 2 over 2, so
I'm sorry.
remember over 2 over 2's.
Equal to 0. Well, if I divide these two, I don't get 0, I get 1.
Oh.
So
Oh, yeah.
0 is going to have to be along the, right? It's either going to be along the y-axis or along the x-axis. So if I do y-axis, 1 over 0, y over x, is that a real number? That's not a real number, right? So the only 0 I'm going to get is y over x here. 0 over 1, that makes sense. That's a real number. And this also makes sense here as well, right? 0 over -1. So at 0 and at pi. All right, now where's tangent equal to 1?
We're on the 1 over 2 over 2.
Yep, power 4, right? So where's tangent going to be positive?
But just that.
First and
Only in the derbies are both negative.
they're both negatives, yeah. First and third. What's a variation of power 4 in the third quadrant? Power 4. Okay, 34. Anybody know what we can do first here? Yeah, the thing is, if we take out GCF of cosine, then we gotta deal with that 1 there. We can't do GCF with a 1 sitting here. We got to bring everything over to one side. We got to get the 0 to show up before we do anything with. So there's no way around trinomial factoring here. We got to. So if it helps, maybe we can do an easier version of this problem, right? Replace every cosine with x. Right? How would you factor this? And once we can factor this, then we can bring the cosine back. I can figure out what multiplies to be. Multiplies to be -2, adds up to be -1. Oops, I got the sign mixed up. So once I get my factored form, let's bring back the cosine. Cosine x equals -1/2. All right, so where's cosine equal to -1/2? Yeah, it's going to be in that second and fourth quadrant. It's going to be in that pi over 3 family. Sorry, 4 pi over 3. Yeah, second and third quadrant.
Yeah, X equal to or just like thetas.
Theta, right. Sorry, I brought back cosine, but I forgot to do theta. Right, and then where's cosine equal to 1?
0.
Yep, 0 and. Well, sorry, just 0, right? 0 and 2 pi. But we leave 2 pi out of it since it's not far. Yeah, because of our domain restrictions. Okay, your homework is the rest of this page, 35 through 38. And then we'll start our trig derivatives tomorrow. All right, come get your phones.